So 1, 2, 3, 4, 5, 6, 7. Here's our major energy levels, 1 through 7. Well, the first energy level only has a 1s. That's the only sublevel that the first energy level has. The second energy level has a 1s, not a 1s, wow, a 2s, and a 2p, right? Second energy level has an s and p sublevel. Third energy level has an s, a p, and a d. So there's nothing really here. The fourth energy level, though, has a 4s. It's got an s sublevel, it's got a p sublevel, it's got a d sublevel, and it has an f sublevel. Fifth energy level now, as we said earlier, there should be another energy sublevel here. There should be. It should be a 5 like G, if you will. But we don't have atoms with enough electrons for that to even exist. Same thing with the sixth energy level. We have 6s, 6p, 6d, and 6f. There could be 2 more sublevels there, but again, we don't have enough atoms or electrons in any given atom that we know of that are large enough to keep those filled. So these higher energy levels only have these sublevels. Now, I'm going to erase this for now. Keep it nice and clean. So what happens is these don't fill in that way. We just noticed that. We didn't go 1s, 2s, 2p, 2s, 3s, 3p, 3d. We saw that it went 1s, 2s, 2p, 3s, 3p, 4s, then 3d. With the titanium example. What? Follow. If we make a bunch of diagonal lines or arrows that guide us through this grid, it will tell us the order in which the sublevels will fill in when we have high amounts of electrons. If you start here and go across this way, it's going to tell you to go through, hey, you're going to fill the first 1s energy level. Well, that makes sense. We know that. When that's done, we're going to go to the beginning of the next arrow, which is the next set of diagonals. Hey, you went here, you're there, okay, now you're done, go here. Okay, now we're going to go through the 2s. Okay, that makes sense. We filled the 1s, now we filled the 2s. Okay, that arrow's done. Now you go here. And you go through the 2p and the 3s. Okay, so we filled the 1s, then the 2s, then the 2p, then the 3s. Then, after the 3s is filled, we go and fill the 3p. And then we fill the 4s. When that arrow ends and the 4s is filled in, then we go to the 3d. Then the 4p. Then the 5s. I don't know. After this transition, we went from the 4th energy level to the 3rd energy level, back to the 4th, now to the 5th. We didn't even finish the 5th. We started the 5th. We didn't finish the 4th, I mean. But that's the way it happens. That's the way all this overlap goes. So we finish this. They fill in this way. We fill in the 3Ds. Then we fill in the 4Ps. Then we fill in the 5Ss. Then once the 5Ss are filled, then we go back and start filling the 4Ds, the 5Ps, the 6Ss. And when they're filled in, then we go back to the 4Fs, the 5Ds, and you get the idea. But if you can list the energy levels with their appropriate sublevels and then draw a set of diagonal arrows, you have a map of how these sublevels will fill in. And this is what Mother Nature does. And so now I can give you an element with 80-some electrons. And you should be able to tell me how and where and why they fill in with their electrons in the cloud. You just have to follow this map. I mean, it's not fun, but it's possible. To that end, let's do something fun. Let's do platinum. No, let's do gold. Let's do gold. I'll do gold. 79. 79 electrons. So AU, 79 electrons. I have to fill in 79 electrons. I have to start at 1s. That's 2 electrons. Then 2s. That's 2 electrons. Then 2p. That's 6 electrons. Then 3s. That's 2 electrons. Then 3p. That's 6 electrons. So I went from here to here to here to here to here. And then according to the arrows, after the 3p, I go to the 4s. I'm following the arrows. That's 2 electrons. Remember, an s can only hold 2 electrons. A p can only hold 6 electrons. Now, let me rewrite this 6. How many electrons did I use? Well, I used 2 plus 2 is 4, that's 10. 8, that's 20 electrons I've used so far. 20. I still got a ways to go. I got 59 electrons still to go. Oh boy. All right. Well, I filled the 4s. What's next? 3d is next. And that can hold up to 10. 10. D's can hold up to 10 electrons. Once that's filled, then I go to the 4p. That's 6 more. Then 5s. That's 2 more. So I'm just following the arrows and filling in what I know. Follow, follow, follow. There's a 3D to the 4p to the 5s. Okay, I got to check in. I got 10, 18, 20, 36, 38 electrons. Oh, I got a lot more to go. Okay. Well, after the 5s, I go to the 4d. 10 electrons. Then I go to the 5p. 6 electrons. Then I go to the 6s. 2 electrons. I'm not done. I don't think so. I gotta reach 79. Okay, I gotta double. Okay, I got 2 plus 2 5, 10, and 20, 30, 36, 37, 38, 48, 56. I still got 56. I still got what, 24 more to go? Oh my goodness. Well, okay, after the 6s, what's next? 4f. 6s, then 4f. All right, so I'm running out of room over here. I'm going to write it down here. Now we jump to the 4f, and that's 14. Remember, I told you we have 24 more electrons to go. Okay? Sorry, Belle. I have 24 more electrons to go. Well, that just took a big chunk out of it, didn't it? And then I go to the 3 or 5d. So, I think I miscounted. I said 24. I don't think that was right. 5d. So I know I'm close. So let me double check my math. 10, 20, 30, 36, 37, 38, 48, 56, 56, 60, 70, I'm 9 away. 9 away. That means that this is going to be D9. I didn't quite fill the D because the D can hold 10. I have D9. This whole thing is my electron configuration. Yeah. Yeah. And now you got to draw arrows. Yeah. We have to draw arrows for this whole thing, and I'm going to make you do it. So you can utilize this grid in any way for any element of the periodic table. You just have to follow the arrows and put the right possible electrons in the right sublevels. Now it's just following a pattern. So I'm only going to do this one example. And you should be able to come up with any configuration that I give you. Now, now that I know all this, of course, The orbital diagram is ridiculous. 1s, 1, 2, 2s, 1, 2, 2p, 1, 2, 3, there we go. 3s, 1, 2. All right, then we're gonna go 3p. 4s has to be in order. Has to follow this exactly. Now check this out. 3d. 3d can hold up to 10 electrons. That's 5 orbitals. 5 boxes, 5 lines. 10 total electrons. Divide that by 2. 5 pairs, 5 orbitals. Remember, all ups first, and downs. Okay, 4p. 5s. 4d. All ups and downs. 6s. No. 4d. 5p. 6s. Oh wow. Come on, Tapper. And then 4f. Actually, it's not even enough room. I'm not gonna squeeze it in here. So 4f. And by the way, this is slightly a bit of a lie the way we're filling it in, but it's good enough for us for now. I know hardcore chem people will beat me up on it, but that's okay. 4f, 14 electrons. 14 electrons, that's 7 pairs. 7 pairs. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So I don't need this. So you need 7 boxes. 1, 2, 3, 4, 5, 6, 7 up arrows. And 7 down arrows. And then we finally, 3, where did we get the 3 from? I don't know. 5D. We need 1, 2, 3, 4, 5 boxes. Up, 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 up. Then down, 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 and down. This last one, that's an unpaired electron, right? So it didn't have a full complete. So this is the configuration, and here is your orbital diagram, and that is one problem. And you're gonna get a bunch of these. They're tedious, they're long, they're a pain. Not hard, just tedious. All right, so get ready for those. In a minute, I'm gonna show you some shortcut methods. Not really a shortcut method, more of a shorthand. All right, see you soon.